Hello, I'm Doug Wicks. I'm a Program Director at ARPA-E, and I'm glad to talk to you today.
And I'm Nick Rodricks. I'm a Waste to Energy Summer Scholar with Doug, also at ARPA-E.
Today we're here to talk about really garbage and trash. And what do we do with our municipal solid waste that goes into landfill? Nick, have you thought about what's in your garbage can?
You know, Doug, after working with you for this past year, I definitely think about what's in my trash. In fact, I brought some trash with me. I just thought I could show you some of the things, the varied items that are in my trash can. First one I found is this broken bike light. I just threw it in the trash. I don't really know what to do with it. There's a sparkling water aluminum can in here that probably shouldn't be in there. Bunch of paper and this plastic thing that I also don't know what to do with, so I just threw it in the trash. And like I was saying, this year I've realized just kind of how varied our trash is and how much of it. Doug, how much trash do Americans produce?
Well, if you take a look at the total trash production by the United States, it's approaching 1 ton per person. So the EPA says about 250 million tons of municipal solid waste are picked up every year. And this is our daily household trash that we throw out. The vast majority of that, is going to landfills at the current time, but we need to find a solution for it.
I know the thing that people always say to me when I start talking about trash is shouldn't we be recycling everything? Recycling is the thing everybody loves, and I love to recycle, obviously. But Doug, can we recycle just everything we put in our trash and get ourselves, out of the landfill?
That's a great aspiration to look at, but there's a lot of material within our trash that just inherently can't be recycled. It's either contaminated or it's a combination of incompatible materials, or there is no end market for what we would recycle. I mean, there's a lot of stuff we just don't want back.
Right. I know since I've been working with you, Doug, you always talk about how Americans, we have 2.5 million tons of kitty litter that we have to get rid of somehow. I'm a dog owner, so I thought, how much dog poop is there? There's 21 billion pounds of dog poop produced in the U.S. So, that can't be recycled, and we have to have something to do with it. Even the best nations, that recycle at the highest rates. So, Norway, Denmark, those countries that recycle close to 50%, that's 20% higher than we do in the U.S. So in the U.S. we recycle about 30%, but that last 50% they have to do something with. So in those countries, Doug, what do they do with that final 50% of trash?
In the leading economies of Europe and actually around the world, Japan also, and other Asian countries, waste to energy processes are used to dispose of the final trash solutions. What they do is burn the trash, and the trash, then the heat from that is used to generate electricity or power district heating systems within cities. So really eliminating the need for other fossil sources by recovering the energy from our trash. And as you say, 50% is about the maximum people can recycle. Looking at this graph that the best countries, have nothing going to landfill, but end up with about 50% going into waste to energy processes to recover the energy versus throwing it out.
So I know in the U.S., we send the majority of our trash ends up in a landfill. But that makes me think now, what kind of energy is stored in all of that trash? So, if we have all of it, what kind of energy capability is there if we could extract it?
There's several forms of energy within our trash. First, you have to look at the thermal energy that would be released from from burning the material. And that's about 11 million BTUs of thermal energy that can be recovered from a ton of municipal solid waste. It's actually pretty close to the amount of energy we get from burning a ton of coal. The other thing to look at in terms of energy is the materials that are in there that have to be replaced if they're not recycled. About 10% of our trash is metal. There's a large amount of other components in there that, as a material scientist, I look at and say should be usable as a construction material if recovered properly. And if you add it all up, the amount of energy that's in our trash that's currently going to landfills is about 5 quadrillion BTUs, or 5% of the total U.S. energy demand.
That's a pretty crazy number, if you ask me. And now this is the part that I've been really excited about since you've been kind of bringing me into this is, besides just that energy potential, which is huge, what else valuable comes from the waste energy process? So at the end of it, what else valuable do we have to use?
Well, the programs that we're looking at, Wicks and Midas, to go into this area, Midas is focused on how do we recover the metals out of the combustion residue. So let's say we take the trash and recover the energy out of this and put it to use. The ash contains a high amount of metals that we can recover, and this includes normal things such as iron and copper and aluminum, but also the residue that comes from our consumer electronics that are not recovered. So this is the key materials, critical materials needed to power our economy. Then looking at the rest of the material, the Wicks program, Waste into X, there we're looking at taking the residual trash, or the combustion residue from the combustion of trash, and redeploying that towards a construction material, which could be very well fit. I mean, it's interesting to think that this material right now probably could be used as a construction material. However, it's highly variable. It's the idea of garbage in, garbage out, that every day our garbage is different. So every day the ash or combustion residue is different.
So maybe you can tell me a little bit more about some of the performers that we're working with at ARPA-E and the specific things that they're trying to solve using that waste energy process.
If we look at the Midas programs, for example, this is the metal recoveries. We have Yetming Chang up at MIT is looking at a very novel electrochemical process to say, how do we completely separate our combustion residue back to the individual elements for reuse. So really trying to use all of it in that process. Or a small company out in Santa Barbara, Lixivia, is looking at a chemical process for doing something similar to say, how do we extract out these very valuable minerals or very valuable metals from the residues. On the waste into X side, or Wicks side, there's a number of different approaches looking at this. So we have Rick Ryman at Rutgers University is looking at co-processing of construction and demolition waste. So taking the construction waste we have and co-processing this with our municipal solid waste to use the energy to decompose this other waste and turn it into a valuable construction replacement. Carolyn Dry of Environmental Solutions out in Minnesota is doing something very similar. However, there she's using waste coming out of the mining industry to say, can we make a value-added product out of it? So there's some really neat stuff that's taking place.
Yeah, that's all really, really fascinating. I think it's our projects are so cool. Maybe you could just wrap up, Doug, by telling me, when I first started, you were talking about construction material, and I didn't really understand, why is this an energy project? So why is ARPA-E so interested in what we can get out of that trash?
Okay, thanks, Nick. I mean, if you go back again, to this, looking at the energy I mentioned earlier, there's about 5 quadrillion BTUs worth of energy sitting in our garbage. That's 5% that's really almost free for us to recover. The other thing to think about is the impact on our energy and our environment of the materials we would replace by recovering these. So that metal that we would recover, the 20 million tons of metal, that also has a huge impact when we look at mining, and processing that metal. So overall, the impact is large on energy demand and on the environment.
It's just really cool stuff, Doug. Thanks so much for teaching us all about it. And I know during the holidays, my family's really looking forward to me spending the whole time talking about trash. So thanks again for that.
Okay, good. All right, Nick, stay safe.
All right, see you, Doug.